precondition. We move on to line 1. Line 1 is easy. B gets initialized to 0. Line 2, E gets initialized to bar 1, bar A bar minus 1. Bar A bar is 8. Very good, because we have 8 elements in the array. 8 minus 1 is 7. Then we go to the repeat until loop. The first line we go execute is line 4, because line 3 is nothing more than a marker to mark the beginning of the repeat until loop. Go to line 4. What do you think M should be in this case? The floor of B plus E divided by 2. B is 0, E is 7, please 3. Well, it's the floor of 3.5, which is 3 itself. Then we go to line 5. Line 5 has a comparison. A bracket M is less than K is that true or is that false? M is 3. A bracket M refers to A bracket 3, which is 7. K has a value of 9. So the question is 7 less than 9?
Yes.
The answer is true. We go to line 6. Line 6 is going to update B. M is 3. 3 plus 1 is 4. So B will now be updated to 4. And after that, we go straight to line 10. Because the conditional statement is all done, we have to get to the until line to evaluate the exit condition. And here we may need to use up some more space. A bracket M equals to K. Is that true? We just did the comparison. We know that is not true. Okay. Well, since this is a disjunction, we have to take a look at the second one. Is B greater than E? B is 4 and E is 7.
No.
B is greater than E is also false. False and 4 false or false is false. Okay, so there we go. We have the entire thing being false. That means we have to go back and perform another iteration. We start with line 4 again. Line 4 this time will calculate 4 plus 7 divided by 2 and take the floor of that. 4 plus 7 is 11. 11 divided by 2 is 5.5. The floor of 5.5 is 5. So M, it becomes 5 this time. Then we go to line 5. Line 5 is doing the comparison. A bracket M is less than K is
false.
It is false, exactly, because now we are comparing 10 to 9. So this time it is false. Then we go to line 7, because this is a multi-branch conditional statement. We have another condition to evaluate if one is false. K is less than A bracket M is
True.
It is true. Okay, it is true because K is 9 and A bracket M is A bracket 5, which has a value of 10. So this is actually true. We go execute whatever code is on line 8. Line 8 says we have to update E. E will become M minus 1. M is 5. 5 minus 1 is 4. And we are done with the conditional statement, because every time you're done with one branch of a multi-branch conditional statement, you're done with the entire conditional statement. So this time we are done with the conditional statement. We go straight to line 10, which is going to evaluate the condition. A bracket M equals K is
False.
It is false. B is greater than E is false. False or false is false. Okay. Then we have to go back to line 4 again, which is the beginning of the entire loop. And this time we have 4 plus 4 divided by 2, and take the floor of that. What is that? That's easy. Yep, it's just 4. Okay. Then we go to line 5. What is line 5 going to say? A bracket M is less than K. A bracket M is A bracket 4. A bracket 4 has a value of 9. Is 9 less than 9? Nope. Okay, so we say the condition of line 5 is false. We go to line 7 because this is a multi-branch conditional statement. Line 5 is asking, is K less than A bracket M? Is 9 less than 9? It is false again. Okay, so we have to spell out the condition and then say it is false. Then we are out of the conditional statement. There's nothing to execute inside the conditional statement because I just took out the else. There's nothing to do. So now we are back to line 10 again. A bracket M equals to K is
False.
what?
True.
What? It is true, and because we are using the short-circuited Boolean evaluation, remember short-circuiting or being lazy? If we can conclude the result of the entire operator early on, we don't evaluate the right-hand side.
But this is or, so I mean, it doesn't matter anything, right?
It does matter, because if this is an OR and the first one, the left-hand side, is true, that means the whole thing has to be true.
Yeah, right, that's what I'm saying.
Okay, all right, I misunderstood. Okay, when this whole thing is true, we get out of the loop. We go to line 11. Oh, I need one more column, just one more. Okay. Well, that's why I like using a spreadsheet for this, because I can easily insert another column. Well, we can always append it all the way at the end. I mean, that's easy to do on a piece of paper, too. Or you can take your razor and Scotch tape. You can just cut, splice, make it wider, insert a column.
Oh my God.
The true cut and paste. Okay, so what do we do with found? Found initially is unknown because we know that we will give it a value at the end. What is the value of a bracket m equals to k?
It's the k values in here, right?
Wait. Okay. What type of expression is this? Okay, let's just take a closer look here. What is the type of the expression on the right-hand side of the assignment statement? It's a comparison. Okay, it's a comparison. All it is asking is a bracket m the same as k? Well, is it? It is true. So what do we do with the value true? We use it to update found, just like any other assignment statements. Okay, just because we have a Boolean value on the right-hand side doesn't mean that it cannot be done, because we can always do this. Okay, in other words, we are using found as a variable to tell the rest of the algorithm or the rest of the program, yes, we have just found the value k in the array. Is that okay?
Yeah.
Okay, very good. So that's exactly the same as what we have talked about on the whiteboard a little bit earlier. It's exactly the same order of moving the B and the E. Any questions about binary search at this point? No questions? This is pretty easy, huh? Did I talk about, the time complexity of a search algorithm last time? No? Did I talk about a colleague of mine? We are trying to see, who gets to stay with the company because my boss says, we can only keep one programmer. We did talk about that? Very good. Now that we have talked about that, did we talk about NP complete? Did we talk about pizza delivery? No? Oh, it's a good time to talk about that. But Pizza, more pizza.
What are you saving this as?
I'm saving it as binary search, but the folder is called 2010, 10, 18. I always use the date as a part of the file name because this way it is automatically sorted by date. And the file name implies what day what day it corresponds to. Okay, so let's kind of take a broader look here. If you guys still remember, the example of linear search versus binary search, even though I was using a 386 SX computer, I was able to beat my colleague who was using an i7 quad-core processor running at 3 gigahertz. Do you guys remember that example that we talked about the other day? Or no? So we never talked about that. Okay.
Yeah, you said just basic.
Okay, all right. So here is a table. I can also use a spreadsheet to capture that idea. Did we? We must not have used a spreadsheet because otherwise the file will be there. Okay, so we'll go ahead and talk about this. Okay, so we'll talk about bar A bar here. In other words, when my boss says, tag and Peter, okay, Peter is my colleague, and my boss said, tag and Peter, I can only keep one of you. So why don't the two of you have a little programming competition here? Okay, whoever can come up with the faster way to find, to confirm whether a value exists in an array or not, gets to stay in the company. And the other one has to be fired because we just moved that position overseas. Okay, So Peter and I, are now, going head to head in a competition. Me being an old timer, has an older computer. So I'm using a 386SX computer as my desktop computer. And Peter, being a new employee, he just joined the company last month. He has an i7 700 series computer, which is running at 3 gigahertz with at least 4 cores. Okay. So Peter looked at me and go, Tag, I'm going to smoke you. I mean, you are leaving this company. You might as well just pack now. I look at Peter and go like, well, maybe not. Okay, we'll see. Who gets to leave the company, who gets to stay. So Peter, being so confident that he's going to win, and not having taken a class like this one, went online, go to Wikipedia, and look for search algorithms. The first one that popped up, or the one that most people use, is called the linear search algorithm, which we have talked about already. So he looked at the search algorithms. He looked at binary search, he looked at linear search, and he said, linear search is so much easier to write, I'm going to use that one. I mean, how bad can it be? It's a very simple algorithm. And me, on the other hand, having taken a class like this, decided, I think I would like binary search a little bit better. Even though it looks a little longer, it looks a little bit more complicated, I'm convinced that it is a better algorithm to use. So here we have a competition. Column A represents the number of items in an array. Column B represents how many times my algorithm has, how many iterations, tags iterations. How many iterations do I have to go through to confirm an element or a value is in the array or not? And column C is representing how much time I need in order to get it done. Column D is representing, in Peter's algorithm, how many iterations it needs to confirm an element or a value is not in the array. And the last column is representing how much time Peter's algorithm will take on his computer to execute that particular algorithm. We start with 1. In my case, I need exactly one comparison to say whether that element, the only element, is the value that I want or not. Right? Do you guys do remember when you have one single element, B equals E equals to 0, and we have one comparison to perform, or one iteration to go through. And I'll just use 1 as a standard time. So this is a standard unit of time. Is basically how long my algorithm will take per iteration. Peter's algorithm will also take 1 iteration, and because he has a super duper fast computer, we'll just say that the execution time of his algorithm, let's see, the two processors, the 386SX processor versus the i7 processor, they are off by how many years?
At least 10.
I thought it was about 24 years or so, something like that. So in 24 years, I think the order of magnitude, according to Moore's law, which means the processor speed doubles every 18 months, within 24 years or so, his computer, in theory, will be 65,536 times the speed of my computer. So we'll just go with that theoretical number, okay? So we'll just say that Peter's time is going to be the number of iterations that he needs, and divided by 65535, which is a tiny number. That's how much time his computer needs to execute one single iteration of the linear search algorithm. Okay. So my boss says, well, Tag, I'm sorry, but you have to leave. Okay, you have to pack. And I said, but hold on, boss. Let's make the array bigger. Let's make it 3. If I have an array of 3 elements, how many comparisons do I need? Oh, actually, we have 3 elements here. It has one single center element. If I pick the center element like this one, I can either eliminate these 2 in one single comparison and have 1 left, or I can eliminate the other 2 and only have 1 left. In either case, I know that I need only 2 comparisons because I already know